Hi students, we are going to see cycloidal curves. Cycloidal curves. Cycloidal curves are 9 curves. One is a cycloid, it's 2 trochoids. Epicycloid, it's 2 trochoids. Hypocycloid, and it's 2 trochoids. Altogether we have got 9 curves. What is meant by cycloid? If you assume a circle rolling on a straight line, and if you take a point on the circumference of the circle, the path traced by that point when the circle rolls without slipping on the straight line is called a cycloid. You can consider the wheel of your cycle. You assume a point on the circumference of the tire, and suppose your cycle is you are riding the cycle. The path traced by that point on the tire circumference is called a cycloid. It goes like this. If the rolling circle rolls on a curved surface through the outside of the curved surface, you get an epicycloid and there are 2 trochoids. If the circle rolls inside of a curved path, you get a hypocycloid and that also has 2 trochoids. We will see what exactly a cycloid is. I will try to show you a circle actually rolling. Okay. Students, we are going to see cycloidal curves. Okay. Cycloid is the path of a point. Where is the point? The point is on the circumference of a circle. What happens to a circle? The circle rolls on a straight line without slipping. Okay, so the definition of cycloid is as follows. The path traced by a point on the circumference of a circle when it rolls without slipping over a fixed straight line is called a cycloid. I am trying to show you an actual cycloid. This is a circle. This is a circle. There is a point on the circle, on the circumference. You can see a white dot. I hope you can see. I am going to roll this circle on a straight line without slipping. You closely watch what happens to the point. The point which is initially at the bottom, that is at the point of contact of the wheel on the ground, comes slowly up and then comes back to the ground position. I am going to roll the circle. You closely watch what happens to the point. You closely watch the path of the point. Okay, roll. You see the point. What happened to the point? The point came up from the ground slowly and then reached the ground once again. Agreed? That path of the point is called a cycloid. Agreed? Now, the point can be inside the rolling circle. If the circle is a disc, this point can lie inside the circle. The path traced by the point inside the circle is called an inferior trochoid. Trochoid, inferior trochoid. Agreed? The path traced by the point outside. How does the point lie outside? It can roll on an edge, just like the wheel of a train. It can roll on an edge. So the point which is protruding outside will trace what? A superior trochoid. Agreed? We are going to see how the trochoids and the cycloidal curves are drawn. Okay? We will see it later. Now, let us do a problem. Draw cycloid of a circle 50 mm diameter. Draw normal and tangent at any point on the curve. That's the question. When you are generally said as draw a curve, you draw the curve once. That is, the path traced by the point when the circle rolls only once. That is sufficient. Okay. What we do is, draw the circle. Draw the circle. P is the bottommost point. Draw a straight line whose length is equal to PA, where PA is equal to pi d. PA pi d. Divide the circle and the circumference pi d into 12 equal parts. And mark them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, finally 12. Divide this pi d into 12 equal parts. You know the procedure of dividing any line into any number of equal parts. What is it? I will just explain it here. You have got this line to be divided into say 3 equal parts. If it is 3 centimeter, you can very easily divide it. If it is not 3 centimeter, if it is not easily divisible, what we do is draw any line at any angle. Draw any line at any angle. Take any distance in your divider or compass and mark it 3 times. 1, 2, 3. Why 3 times? Because you want to divide this line into 3 equal parts. Join the last point to this point. Then with the help of 2 set squares or a set square and a scale, draw lines parallel. How are they drawn? Keep the side of the set square here, lock the other side, then move. Agreed? I repeat. Keep this side here, lock the mobility of the other side, then move. Draw lines. Agreed? Some people move both. Wrong. You have to keep one side locked and the other side can be moved. Okay, you know those things, I am just explaining, however. Okay, so you can adopt that method to divide this circle, this pi d into 12 equal parts. I am for doing it for convenience. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and 12. What does it mean? When the circle rolls, 1 come to 1 dash, 2 come to 2 dash, 3 come to 3 dash, 4 come to 4 dash, and so on. What happens to the center C? C will move. So what we do is draw horizontal lines through all these points. Horizontal line through 9 will pass through C as well as 3. Very light lines. Very light lines. Instead of light, I am slightly making them dotted. Actually, they are very light lines. So, where is the path of C when 1 come at 1 dash? C will come to C1, C2, C3. They come right above this point. C3, C4, C5, C6, C7, C8, C9, C10, C11 and C12. Agreed? Now, if P is the tracing point or P is the path, P is the point whose path is traced. When 1 comes to 1 dash, what happens to P? P moves up from the ground. Where is P? C1 as center, C1 as center, radius as radius, whatever the radius of circle, cut the line through 1 at P1. Line through 1, this is a line through 1 at P1. Then C2 as center, cut the line through 2 at P2. Then C3 as center, cut the line through 3 at P3. C4 as center, cut the line through 4 at P4. C5 as center, cut the line through 5 at P5. C6 as center, you need not cut, it is right above P6. Then you get similarly P7, P8, P9, P10, P11 and P12. P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12. Connect them by a smooth curve. Connect them by a smooth curve. What you get is called a cycloid. P moves like this and comes back. This line over which the circle roll is called the directing circle. And this circle which roll is called the rolling circle. Agreed? Here the rolling circle and the generating circle are the same. Generating circle is the circle which contains P. P is not the rolling circle itself, so the rolling circle and generating circle are the same. When the point is inside or outside the rolling circle, we draw that circle and that is the generating circle. Rolling circle remain always the same. Now you are asked to draw normal and tangent at any point. Let K be the point where you want to draw the normal and tangent. When P is at P7, center is at C7, and the point of contact is at 7'. When P is at P8, center is at C8 and the point of contact to the wheel on the ground is 8'. When P is at K, where is the center? Radius, 25 mm radius, cut an arc between C7 and C8 to get L. Drop L down. M. What is M? M is the point of contact to the wheel on the ground when P is at K. Join MK and extend. That's a normal. A perpendicular to that is the tangent. I hope you understand. Now, there can be situations when a circle further roll. If it roll again, what happens? The same curve is repeated. The same curve is repeated. If it rolls once again, full circumference, the same will be repeated. Suppose it rolls some more distance. The curve will stop somewhere. The curve will start from here and stop somewhere. We are going to see, or we have such university questions. One question is, the circle 50 mm diameter rolls on a circle which is 20 cm length. 20 cm length. So what we do is, draw 20 centimeters. Draw 20 centimeters. Draw 20 centimeters. This is pi d. So this is 200. This is 200. What do you do? Divide the mark pi d, divide it into 12 equal parts. Same thing. Now what? Take this distance in your divider, mark it once more. What do you get? 13 dash. Mark it once more, you get 14 dash. Mark it once more, you get 15 dash, and there is some more distance remaining. PB is the line, 20 cm long. 13 dash, 14 dash, 15 dash, and 16 dash. What happens to the center of the circle? Center of the circle similarly move to C13, C14, C15, and the last point you call as C16. This 1 becomes what? 13, 2 becomes what? 14, 3 becomes what? 15, and this small distance you mark from 15 upwards you call as 16. Okay? You have got horizontal lines to 13, 14, 15. There is no horizontal line through 16. Draw an additional horizontal line through 16. Okay, up to this much is sufficient. This is not there. Now, what is to be done? Now, what is to be done? C13 as radius, center, 25 mm radius, cut an arc on the path through 13 at P13. C14 as radius, cut P14. C15 as radius, cut P15. C16 as radius, cut P16. This is C. Extend the curve. The curve reaches here, then P13. This is P13. P13, P14, P15 and P16. It ends there. If it further rolls, it will go on. That is a procedure of drawing a curve when the cycloid or when the circle rolls further. This question has come for university exams numerous times. This has come for university exams numerous times in various universities. Very simple question. Agreed? Now, hi students, if the tracing point is inside the rolling circle, it is an inferior trochoid, and if it is outside the rolling circle, it is a superior trochoid. Let us draw an inferior trochoid of a circle 50 mm diameter when it rolls once, and the tracing point is 18 mm away from the center of the rolling circle. Agreed? 18 mm away from center of the rolling circle. We also draw a superior trochoid generated by another point 32 mm away from the center of the rolling circle. So the inferior as well as superior trochoids I am going to draw on the same circle. Agreed? We draw the rolling circle. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. One dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Length PA. Center C. We are identifying the centers position, the position of the centers C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. Now, this is the point P whose path is called a cycloid. Agreed? Now, there are two ways of doing it. The easiest way, which I will advise you to follow, is locate the path of P. How do you do that? C1 as center, cut P1, C2 as center, cut P2, C3 as center, P3, C4 as center, P4, C5 as center, P5, C6 as center, P6, P5, P4, P3, P2, P1, P. Similarly, P7, P8, P9, P10, P11, P12. Just like in the case of a cycloid. Then, don't draw the cycloid. Instead, connect C1, P1. Extend. Connect C2, P2. Extend. Connect C3, P3. It's already there. C4, P4. C5, P5. C6, P6. C7, P7. C8, P8. C9, P9. C10, P10, C11, P11, C12, P12. extend those lines. Now, if you are drawing inferior trochoid, where is the tracing point? Tracing point is here. Why call it I? 18 mm away from the center I. Take that 18 mm and mark from C1 P1. Mark on C1 P1 line. What do you get? I1. C2 P2 line. I2. C3 P3 line. I3. C4 P4 line. I4. C5 P5 line. I5. C6 P6 line. I6. C7 P7 line. I7. I8. I9. I10. I11. I12. Connect them by a smooth curve. It starts with a bend here and end with a bend there, small bend. I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12. Now, suppose you want to draw normal and tangent at this point called K. 18 mm radius. K is between I4 and I5. So between C4 and C5 there must be L. Take 18 mm and cut an arc. You get L. Drop L down. M. MK is the normal. Perpendicular to that is the tangent. This is the normal. This is the tangent. This is the case of an inferior trochoid. If it is a superior trochoid, where is our tracing point? Tracing point is here. Yes. Where is it? 32 mm away from the center. On C1 P1 extended, locate S1. C2 P2 extended, locate S2. C3 P3 extended, locate S3. C4 P4 extended, S5. C5 P5 extended, S6. S4, S5, S6, S7, S8, S9, S10, S11, S12. Connect them. S, S1, S2. S, S1, S2 up to S12. Suppose you want to draw normal and tangent at point K. SC is between S7 and S8. So P is at L is between C7 and C8. Take 32 mm in radius, cut an arc. You get L. Join KL. Drop it down. M. MK is the normal. Perpendicular is the tangent. In this case also, the circle can roll further. Circle can roll further. What happens? This is the line. If the inferior trochoid roll further, what happens? It starts with a bend and goes like this. It starts with a bend and go on like this. Just like the starting point, it starts with a bend and go on like this. If superior is repeated, what happens? It produces a loop here and goes like this. Produces a loop there and goes like this. The advantage of drawing trochoids after getting P1, P2, P3, that is the path of a cycloid, is procedure is the same. There is no way you can go wrong. Now, if you draw a circle with its CS center and CI as radius, 18 mm radius, this circle is called the generating circle. generating circle, whereas this remains to be what? Rolling circle. And if you draw a circle with CS as radius, which represents the generating circle for the superior. Generating circle for the superior. I hope you understand. Very simple curves. Take some time, you need practice, you have to remember the way the notations are made. Okay then. Thank you.